All right, guys, today's lesson is going to be section 9-2. The homework from last class, if you have any major questions, please send me an email, or we will talk about them at the beginning of class on Tuesday. All right, section 9-2. What we're going to do today is we're going to do the same basic ideas we did last class, but for this class, we're going to be talking about a specific sequence, which we're going to call an arithmetic sequence. All right. Last time we did general sequences where anything can happen to go from one term to the next. When we do an arithmetic sequence, a specific thing's going to happen. So we're going to talk about arithmetic sequences and partial sums. Partial sums is our series where we're going to add together a certain number of terms. I'm going to teach this class a lot faster than I normally would with you guys in the room because I don't have anybody to stop me, slow me down, or ask questions. So as you go through, when I go to the next slide, pause it, copy down what you need to. Start it up again. Let me do an explanation, then pause it, do some work, but back and forth. Do a lot of pausing. Don't just watch it all the way through and expect to be able to keep up and keep all the notes that you need to be taken on your paper. Pause it and do what you need to do. All right, so for a sequence to be arithmetic, we're going to say the difference between consecutive terms is a common variable D. What that means is for a sequence to be arithmetic, you have to add the same value to go from one term to the next. If you're not adding the same value to go from one term to the next, it's not arithmetic. All right, so like last class, we're going to start. I'm going to give you a sequence, and we're going to decide if it's arithmetic or not. And if it is arithmetic, we're going to find that common difference, that variable D, and then find the next two terms. All right, so again, start doing your pauses on your video when you need to. All right, number 1, 7, 11, 15, 19. So I'm going to look at these and see what the pattern is. To go from 7 to 11, I'm going to add 4. From 11 to 15, add 4. 15 to 19, add 4. So that tells me that this is an arithmetic sequence because to go from one term to the next, I'm adding the same value of 4. That makes it arithmetic. So to add 4 to get my next term, 19 plus 4 is 23, plus another 4 is 27. So my next two terms would be 27. So we have to look at the numbers to see what you're adding to go from one term to the next. If I have the same value all the way through, it's going to be arithmetic. Number 2, 25, 22, 19, 16. So as I look at this, it looks like I'm subtracting 3 to go from one term to the next, which is good enough because what we're going to say is that my common difference is a -3. I'm going to add a -3, and we all know that's the same as subtracting. So to get my next two terms, subtract, or add a -3, add a -3, but in our heads we're really going to subtract to get 13 and 10. All right, number 3 we had last time. We looked at it two ways, 1, 4, 9, 16. As I see this problem, looking to see if it's arithmetic, I add 3, I add 5, I add 7, I add 9. We are adding numbers, but we're not adding the same number every time. So this one's not arithmetic. Number 4, 1 comma 5 over 4 comma 3 over 2, 7 over 4. All right. This one, I got fractions. It makes it a little bit harder to look at. So what I'm going to do to make it a little bit easier is I'm going to rewrite this, getting common denominators. I'll make 1 4 over 4, 5 over 4, make 3 over 2, 6 over 4. So now as I look at it, it makes a little more sense to me. And what I'm adding each time to go from one term to the next is 1/4. All right, so I'm going to keep doing that. I'm going to add 1/4 and get 8/4, which is 2, and add another 1/4 and get 9/4. All right, so given a sequence, you got to figure out the pattern. If the pattern is adding the same value from one term to the next, it makes it arithmetic. Our next two lessons, we're going to have 5 formulas total. Our first formula is the one on the board. A sub n equals a sub 1 plus n minus 1 times d. Where a sub 1 is my first term, n is my number of terms, and d is that common difference, and that's going to help me find a specific term, a sub n. We're going to go back and forth using this formula we will have 3 of the 4 pieces that we need. We'll substitute it in and find what we need. So for this first problem, I want to find the 6th term, a sub 6, when my first term is 3 and my difference is -5. All right, so going through the formula, this is what I'm trying to find. A sub n. I have the first term of 3. I have an n value of 6, subtract 1, and my difference is -5. So I have everything I need. So I'm going to go through and do my math. In the 6th term of this sequence, if I go from a 3 and I keep adding a -5 until I get to my 6th term, it's going to be -22. All right, number 6, same situation. You have the first, the difference, and the number of terms. Plug it into the formula. So at this point, pause the video and do the math and restart it to see if you agree with what I have. I substitute what I have in. I keep going through my math. And I get my 12th term to be 41/5. Make sure when you multiply fractions, if you can cross cancel, do that, but if you can't, multiply across the top and the bottom, and make 11 a fraction if you need to. All right, next. The next 3 problems we're going to do 2 different ways. The first way is I'm going to give you the first term, like number 7, where my first term is 15, and I'm going to give you the common difference of 15 also. This one's pretty straightforward. So what I'm looking for is the first 5 terms. I already know the first one is 15, and they're telling me to go from one term to the next. I'm going to add 15, so that's all I'm going to do on this problem. I'm going to keep adding 15. Until I get all 5 terms. Number 8 comes out to be a little bit different though, because this is my situation. I don't know my first 3, but I know my 4th term is 16. 5, 6, 7, 8, 9. And my 10th term is 46. This is what I have. And the problem wants me to find the first 5, so the problem wants these. But we're going to need all of it to be able to get there. So if I look at my formula, a sub n equals a sub 1 plus n minus 1d, to be able to find those first 5, I need to find the d value. All right, so that means I need the first term, the number of terms in the nth term, last term. I don't have the first term. So what we can do to be able to find the first term is we're going to shorten our list. Instead of looking at all of it, I'm only going to look at these pieces. I'm going to ignore the first 3 for now. So what I'm going to say now is my first term now is 16. So I have a first term. My nth term, 1, 2, 3, 4, 5, 6, 7. My 7th term is 46. Now I have a number of terms also, because now I'm dealing with 7 instead of 10. So now I have what I need to find my difference. I do my math. Like I said, pause it when you need to. And I get a difference of 5. To make sure I didn't make a mistake, I'm going to add 5, which is my difference, to the right. These numbers I'm writing in now are not part of the answer, but they get me to where I need to be. They show me that the math I did worked, because we're going from 16 to 46, If I keep adding 5, it works. So now, I need the first 3, so I have the 4th and the 5th. So if I add 5 to go to the right, I'm going to subtract 5 to go to the left, and I get my first 5 terms. So we are going to adjust the numbers that we have. I'm going to ignore terms 1, 2, and 3 for now, and make the 4th term that I'm giving really my first term, and my 10th term becomes my 7th. Now I can use that formula to figure out what my difference is. All right, do number 8. Pause the video. Same situation. You have the 8th term of 26 and the 12th term of 42. There's my ace of 8th. 9, 10, 11, 12 is my ace of 12th. I'm going to limit my sequence and make this one my first, second, third, fourth, and my 5th. So my ace of 5 is going to be 42. My last term equals my first term, plus my number of terms, 1, 2, 3, 4, 5, minus 1, times my difference. Solve, 16 equals 4D. My difference tells me I'm going to add 4 to go from one to the next. So make sure 30, 34, 38. All right, my math works. So I add 4 to go to the right. I'm going to subtract 4 to go to the left. First 5 terms. Same idea, just different numbers to start it. All right, next, we're going to find the sum of a finite arithmetic sequence. A lot of math words. We're going to add together a particular number. We'll start again. Add together a particular number of terms that are arithmetic. It's also called a partial sum. To find the sum of a finite arithmetic sequence, we're going to do S sub n, the sum of n terms, equals the number of terms divided by 2, times your first plus your last, a sub 1 plus a sub n. So if I have the first term, I have the last term, I have the number of terms, I have everything I need. I don't need anything else. I can add them all together. So for number 10, we have the sequence, arithmetic sequence, 2 plus 8 plus 14 plus 20 plus ... up to 25 terms. So I'm going to add together 25 terms of this sequence that goes 2 plus 8 plus 14 plus 20 plus ... All right, so looking at this, I have the first term, great, 2. I have the number of terms, which is good, which is 25. But I don't have my a sub 25. I don't have my last term. I don't have that nth term. So I'm going to go to my other formula. I have the first and number, and looking at it, I have a difference of 6. I can find my 25th term. So there's going to be multiple times where you have to go back and forth between your two formulas. So I plug it in what I have, take a couple seconds, find me that 25th term, and then we'll go back and find the sum. I did my math right, which I think I'm good. My 25th term is 146. So I'm going to come over here and say my S sub 25 equals 25 over 2 times 2, my first term plus my last term. 25 over 2 times 148. To make my numbers a little bit better, I'm going to cross cancel. 2 goes into 148 74 times. Now I'm going to do my calculator and do 25 times 74. You get 1,850. So if I take the series, or the series, 2 plus 8 plus 14 plus 20 plus ... all the way up to my 25th term, which is 146, and add them all together, they're going to add up and give me 1,850. So this whole section is about having the two formulas. You will have enough information. You just have to be able to go back and forth between them. All right, the next one, we're going to add the first 100 positive integers. All right, so reading this, the first 100 positive integers, I can tell right away that my n's going to be 100 terms. They're all going to be positive, and we all know that integers are numbers, no fractions, no decimals. You guys like to call them whole numbers, but they're not whole numbers. They're numbers that have no fractions or decimals. So what we're going to add together is 1 plus 2 plus 3 plus all the way up to 100. The first 100 positive integers. So my formula says the sum of my 100 numbers is 100 over 2 times my first term plus my last term, which is going to be 50 times 101. And without a calculator, if I have to multiply 50 times 101, I'm going to multiply it by 5. 5 times 101 is 505. And because it's a 0 at the end of 50, it makes it 5,050. This one's, once you understand what you're adding together, you have everything you need. All right, number 12 is a little different. We're going to add together the first 50 positive odd integers. First 50 positive. So my thought is, again, I'm going to be adding 50 numbers. And since I'm adding positive odd integers, I'm going to add 1 plus 3 plus 5 plus 7 up to that 50th term. I don't know what that 50th term is. When I do this with a class, some people think it's 49. Some think it's 99, some think it's 101, and some other numbers in between. But unless you're 1,000% sure, we need to figure that out. I don't know what the 50th one is. So what we're going to do, I want to find my 50th term. So I'm going to go to the other formula. My first term I know is 1. I know I want the 50th term. And I know my common difference is 2. So I don't have to sit and guess what it is. I have enough information. I can use the other formula. So I'm going to go 1 plus 49 times 2, 1 plus 98, and my 50th term is the number 99. So I'm adding 1 plus 3 plus 5 plus 7 plus ... all the way up to 99. So now I'm good. I have my number of terms, my first term, and my last term. Plug it into that summation formula. So if we add the numbers, 1 plus 3 plus 5 plus 7 plus 9, blah, 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 plus 97 plus 99, all my 50 positive odd integers, they're going to add up to 2,500. If part of this doesn't make sense, rewind it, pause it, go through it so you can get through what you need. All right, I messed up my numbers. We're going to call this 12B. All right, if we remember last class, this summation notation. To find the formula, I need the number of terms times, or number of terms divided by 2, times my first plus my last. Last class we said, we plug this number in to get my first term. So my first term is 1. I'm going to plug in the top number to get my last term. If I start counting at 1 and I count up to 13, from 1 to 13 is 13 terms. Starting at 1, if you have to count on your fingers, up to 13 is 13 terms. So I'm going to go 13 over 2 times 62. because I like to, I'm gonna cross cancel. 2 goes into 62 31 times. 13 times 31 is 403. So the sum from n equals 1 to 13 of 5n minus 4 is going to be 403. Which says if I plug 1 into this function and get an answer, I plug 2, 3, 4, 5, 6, 7, all the way up to 13 into this function, and I have 13 numbers and add them together, they're going to add up to give me 403. But that's a pain. Knowing this formula and how to get your values makes it a little bit easier. All right, last one. The sum from n equals 50 to 100 of 3n. The sum of n equals 50 up to 300 equals 3, or is 3n. Okay. So, first term. I'm going to plug 50 in. My first term's 150. My last term, I'm going to put 100 in. And that's 300. My number of terms, this one's going to be different, and all of them are going to be this way. Since I'm not starting at 1, I'm not going 1, 2, 3, 4, I'm going 50, 51, 52. To find n, we're going to take the top number, and I'm going to subtract the bottom number and add 1. The reason we have to do this is if all you do is subtract the numbers, you're finding me the difference, and you're ignoring that first term. So I'm going to take the top number minus the bottom number and add 1. To add 1 adds back that first number. And this one has 51 terms. If you start counting at 1, absolutely it's the top number, is your number of terms. But if you don't start counting at 1, do the top minus the bottom and add 1 to count that first one. So now I'm going to find the sum of 51 terms, which is 51 over 2 times my first term of 150, my last term of 300, 51 over 2 times 450. I'm going to go straight to a calculator on this one and get 11,475. So the sum from n equals 50 to 100 of 3n is going to be 11,475. Bottom number, plug it in, get your first term. Top number, plug it in, get your last term. Top number minus the bottom number and add 1 tells you your number of terms. All right, that's today's lesson. As you're doing your work in WebAssign for homework, if you need to, send me a message. I will do my best. I can't promise it'll be done by Sunday night, but I will do my best to get back to you. Have a great day, and make sure we have the homework done when you get to class on Tuesday.